Um, Hello. Here we are going to discuss about signal processing. Myself, Akhil. I did my masters in signal processing domain, and I have 3 years working experience, industrial experience. So we are going to start a new channel, and here we are going to discuss on electronics communication background related courses. So we started with the signal processing course. Coming to here we are mainly discussing about in this video about the what is signal, what is the frequency, what is the wavelength, and what is the phase and what is the amplitude of the signal. So these are the basic of the signal I'm going to discuss here. So what is signal? uh, Signal, whatever it is, passing the information like wireless or wide information, whatever it have the some quantity of information transmitting from one point to another point, it is called the signal. It have some characteristics like frequency, wavelength, and phase and amplitude. So these I'm going to discuss here. Coming to what is the frequency of the signal. So if you see, each audio have one frequency. If you observe like each like we our voice have one frequency, and if you listen some if train is moving with some horn, it that sound has one frequency. So like that, each and every signal have one frequency. So here I'm simply representing with the sinusoidal signal. It is easy to understand. So this is one frequency signal with f1 here, and this is the second signal, it is generated with f2 here. So these all how to generate the signals, like practically also we are going to show you in python code, and we can generate the some signals, and how can we play with these signals we will show you. uh, Currently this is so each signal have one frequency. If you see, observe here, first signal is with f1 frequency, second signal is with f2 frequency. Here one more thing, if you see f1 frequency, that whatever these cycles are there, these are the calling, we are going to call these cycles. So directly, what is frequency means, number of cycles per second is nothing but a frequency. So this is one frequency, number of cycles per second. So f2, it have more number of cycles per second, this is f2 frequency. So if you see, this is we called this cycle length, we call this is wavelength. If you see here one wavelength, it have, this is one more wavelength. So that means if frequency is increased, that wavelength of the signal is decreasing. So as if you see, according to formula, f is equal to c by lambda, lambda is equal to c by f. As f is increased, lambda is going to be decrease. So if you observe here for f1, it has the less frequency, so it have more wavelength. f2 is more frequency, that means more number of cycles per second, so the wavelength is very less. That is about the wavelength. Wavelength we represent in this in meters, and frequency we frequency dimension in hertz. So coming to the next one, phase of the signal. So the frequency is nothing but it is rate of change of phase is we called frequency. If you observe here, this is one signal. So it have the 0 to 360 degree phase. So that's why I am representing here in one circle. If you observe here, this is 0 to 90, here 90 to 180, 180 to 270, and 270 to 360. So it is this is phi 1 phase, and if you observe here, this is the phi 2 phase. So I'm representing here. Suppose our receiver is at this place, and we are receiving one signal. At what phase we are receiving the signal? Suppose maybe another receiver is next to uh, next one, like at what phase this receiver is received the free signal. This is the phase of the signal. These are all are the important parameters while analyzing the signal. So I'll discuss these all things, like where these all things are important, how frequency is a matter, like how the I mean frequencies matter now, why different frequencies for 5G signals, 4G signals, and why we are using different frequency for radar, and why we are using different frequency for the navigation. And so each application have the different frequencies, and why we required different frequency. So these all related information we are going to discuss in further classes. So we will show with some practical applications also at the end of this course. So this is the just about the I want to tell basic information of the signal. So now we'll show in a in program is like how to create the signal, and we'll show here. Thank you.
Signal, its property like amplitude, frequency, phase. In this one, we'll see it in real example in a programming language called Python. In Python, we'll generate a sine tone and we'll see its phase, frequency, and also we'll analyze its period, time period. So this is a piece of a code written in language called Python. It has some libraries called numpy, matplot, lib. All these things, what it will do, it will help in doing some numerical computation and plotting the figures. Now, suppose we have a sine tone with amplitude 5. Pi is a constant in sine generation, we know. It has a frequency of 200 e power 3. E power 3 is 10 power 3 in scientific notation. So it has a frequency of 200 kilohertz and it has a phase of 0.01, another one has a phase of 0.5. Now, what is Fs? So, if you know in digital computing, we need to sample a signal. We can't. So, analog wave is full of n number of points where n is infinity. There's so many closely spaced points which are very close in time. You cannot have the separation between them. But in digital world, we have to store it in a fixed number of points. That means what it try to say Fs is that in 1 second it will take 2000 into 10 power 3 number of samples from a sine tone, equally spaced samples. So that way it is generating a tick called time ticks, which is nothing but np.a range that will generate ticks from 0 to 0.001 second, that is basically 1 millisecond, with a rate 1 by fs, which is 1 by fs is time period of one tick. Now we generate a signal phi 1 and sig phi 2 with both with amplitude a1. Okay. Okay. For the sake of understanding, we'll make the sampling duration of we'll make the tone fc as 200, little less, so that you can see a clean sine tone, which is also in the human like listening levels, 220 kilohertz. So now we'll generate a sine tone sig phi 1, sig phi 2, and plot it using this piece of code. We'll run it and see what is the output. Now, if you see here, if I zoom to a particular part, so we know a period of sine wave is from its peak to peak. Now, if you zoom out and see, red one is phi 1, which is the first sine tone, blue one is phi 2. So, distance between these two peak, any blue or red, any ones, will be its period. So, if you see, red one is, this peak is at say 25. This is time sticks. So red one has a peak at 25, right? And next peak, if you see here, is at 125. So how much is the duration for that peak to peak? It is 120, 125 minus 25, 100. Now we'll make sense how it is correct. So we'll see how many samples will come in 1 second for sampling rate of fs. So if you do 1 by fs, like here if we do 1 by fs, we'll get 5 into 0.7. Okay. Now if we do 1 by fc, what 1 by fc will tell us that how many periods will complete in once, like how many so fc tells how many cycles will complete in 1 second, but 1 by fc will tell duration of one cycle for sine wave. So if we know that one period, sampling period is 5e into 10 power 7, 5 into 10 power 7, but duration of one like cycle is 5 into 0.5. If you divide both, this 5 into 0.5 like this, we'll copy this only and divided by this, we'll get 100. So we see this is the time period of our signal. How it is peak to peak, we have seen 100. So we understand. So what is FC? FC is FC there. FC will tell in 1 second. What will tell? I'll write here in comments. FC tells number of sine wave cycles in 1 second. And what fs tells number of samples of any signal, or here sine wave, in 1 second. So if we take inverse of fs, 1 by fs, what we have done here, it will tell you that duration of one sample. So we are seeing if we multiply this by 100 here, it will give you, because we have seen the duration is 100 cycles. 100 cycles is like 100 in 100 samples, one cycle is completed here. In 100 samples, one cycle is completed. So if we multiply 5e.7 into 100, we'll get the one duration for this one full cycle for sine wave. That's what we got here. If you multiply 5e into power 10 power 7 by 100, we'll get 5e into 0.5. So that's how FC and FS is related, which is time period. Now we'll look at the phase. If you see the phase here, at the 0 time, sine wave, red sine wave, which has a phase of 0.1, is starting from almost 0. It is a little bit above 0, but almost around 0. But the phase, this 0.5 second sine wave, is starting from little bit ahead, above. So more this phi term in your sine expression, it will be more delayed, in the sense, if you see this this blue color curve would have got at 0, around 0 very late, earlier. That means what thing which is happening to sine tone at 2 seconds or somewhere here, suppose, has happened to this earlier only. Both are same sine wave but little delayed. One is earlier, one is delayed. So this phi will tell that how much it is delayed. So that is what it is here. Now amplitude wise, if you see, both are reaching same level. If you see, both are reaching same level of 5. Both are reaching of same level of 5. If you change one of them, like if you put A2 as a, say, 10, and run this, we'll get a plot like this, where, okay, if you have to put A2 here, we'll get A2 as little bit higher, 10. So now see A1 is up to 5 only, but A2 is up to 10. But still that phase difference is there. It is starting around 0.1 and it is starting from somewhere higher. That is different in phase. So we covered amplitude, frequency, and phase, all three in this one. Thanks for watching this video. I hope you understood. If any doubt, you can ask me.